We know that if SC is a 0 of a polynomial f of x, then the binomial x minus c is a factor of f of x. Sometimes, however, that factor will appear multiple times in the factorization. And if this happens, then we call such 0 a multiple 0, and the number of times that that factor appears in the factorization is called the multiplicity of that 0. In general, we'll say that C is the multiplicity k. Then if k is the largest exponent such that x minus c to the power k appears in the factorization of f of x. For example, if I have the function f of x equals, say, x minus 2 squared times x plus 1, the zeros of this function are x equal 2 and x equal negative 1. They are zeros because there is the factor x minus c present in the factorization. Now, factor x minus 2 appears twice, and this is indicated by the exponent. So we can say that that 0 has multiplicity 2. Now, if you look at x equal negative 1, the factor x plus 1 appears only 1. So multiplicity of that 0 is 1. In the example, we have a polynomial function, and we want to show that c equal 1 is a 0 of that polynomial, and we want to determine its multiplicity. Finding out whether c equal 1 is a 0 or not is relatively easy. What we have to do is just compute the value of function at 1. And that value is going to be 1 minus 2 plus 3 minus 1 minus 1, which is indeed 0. So yes, the x equal 1 is a 0 of the polynomial function. Now, if this happens, then function f of x can be written therefore as a product of x minus 1 times q of x. So the factor x minus 1 appears once in that factorization, so we know that the c equal 1 has multiplicity at least 1. Now, could that multiplicity be higher? Everything depends on q of x, whether q of x contains another factor x minus 1 or maybe more factors x minus 1. Now, q of x is the quotient when f of x is divided by x minus 1. So using synthetic division, we can quickly determine that q of x is x cubed minus x squared plus 2x plus 1. And the question is, when figuring out multiplicity, does x minus 1 appears as a factor in this polynomial? To answer that question, we can check whether 1 is the 0 of that polynomial, and therefore we can compute q of 1. Q of 1 will be 1 minus 1 plus 2 and plus 1, which is 3 and not 0. So that means that x equal 1 is not a 0 of q of x, and therefore the answer to the question, is x equal 1 a factor, is no. And therefore x minus 1 appears only once in that factorization of f of x, and therefore x equal 1 has multiplicity 1. So x equal 1 is a 0, and it is a 0 of multiplicity 1.